Hello everyone, welcome to today's chemistry class. Today we will learn about alkyl halides and aryl halides. We will discuss their formulas and classification. So let's begin our journey.
Today's topic is alkyl halides and aryl halides. Aryl halides. So first, halogen compounds classification we have to discuss. So halogen compounds first totally classified into four types. That is the alkyl halides. Second one is the alkynyl halides, and third one is the alkynyl halides, and fourth one is the aryl halides. So this is the classification of halogen compounds. So now halogen compounds means these are the derivatives of, what is that? Derivatives of hydrocarbons. Halogen compounds means these are the derivatives of hydrocarbons. So halogen compounds classified into totally four types. One is the alkyl, alkynyl, and aryl halides. So now in this alkyl halide again classified into different types. That is the monoalkyl halides. Second one is the dialkyl halides, and next one is the trialkyl halides. Next one is the polyalkyl halides or perhalo compounds. This one. Again, this monohalogen compounds again classified into primary halides. Second one is the secondary halides, and the third one is the tertiary halides. So this is one of the classification. And monohalogen compounds again classified into different types based on the hybridization of the carbon. That is based on the sp3 hybridization carbon. Again, three types are there. What are those? Are the one is the alkyl halides, second one is the benzyl halides, and third one is the allyl halides. So this one. Next, based on the sp2 hybridized carbon, totally two types is there. There is the vinyl halides, and second one is the aryl halides. So this is the classification of halogen compounds. First, halogen compounds classified into four types: alkyl halides, alkynyl halides, and aryl halides. In this, alkyl halides again classified into mono, di, tri, perhalo compounds, and after that monohalogen compounds again classified into three types: primary alkyl halides, secondary alkyl halides, tertiary alkyl halides. And one more classification based on the hybridization, monohalogen compounds again classified into different types based on the sp3 hybridized carbon. Three types, that is the alkyl halides, benzyl halides, and allyl halides. And based on the sp2, that is the vinyl and aryl halides. So this is the classification of halogen compounds. So first we have to discuss about halogen compounds. What is the meaning of halogen compounds? Means hydrocarbons. Hydrocarbons means what is that? The compounds which are having hydrogen and carbon, those compounds are called hydrocarbons. So hydrogen and carbon are present. What are present? That is the hydrocarbons are, one is the alkane, second one is the alkene, and third one is the alkyne, and aromatic hydrocarbons also there. So that is the aromatic compounds also. Now here alkane general formula, what is that? Cn H2n plus 2. This is Cn H2n, and alkyne is the Cn H2n minus 2. So this is the hydrocarbons general formulas. Now what we are discussing, halogen compounds. Halogen compounds means these are the derivatives of hydrocarbons. These are the derivatives of halogen compounds are derivatives of hydrocarbons. So means in the alkane or in the alkene or in the alkyne or aromatic compound, aromatic hydrocarbons, on that hydrogen is replaced by the halogen. So replacement of hydrogen by the halogen from hydrocarbon, those are called halogen compounds. For example, CH4, this is the, what is the name of this? Methane. This is, so methane, when you are reacted with halogen, any halogen like a fluorine, chlorine, bromine, iodine, then in the place of one hydrogen, halogen is replaced, then you will get CH3, and one place of hydrogen, halogen will be, so CH3x. So this is one of the halogen compound. So like this, halogen compounds means these are the derivatives of hydrocarbons. Now, so first, halogen compounds classified into four types. On that first one, what is that? That is the alkyl halides. Alkyl halides. So alkyl halides means in alkane, hydrogen, in alkane, hydrogen is replaced by the halogen, then we will get the alkyl halides. For example, C2H6. C2H6, what is the name of this? Two carbons are there, eth, and this is the formula according to alkane. Alkane general formula CnH2n plus 2. Here, how many carbons are there? Two carbons. So n value is the 2. So 2 into 2, 4. 4 plus 2, 6. So C2H6. So what is the name of this? Ethane. This is ethane. So this ethane, in this, when you are reacted with halogen, here one hydrogen from the alkane is replaced by the halogen. Then C2H5x. So this is a alkyl halide. So alkyl halide means a replacement of hydrogen from the alkane, replacement of hydrogen in a alkane by the halogen. So that is known as alkyl halide. Next, second one is the alkynyl halide. This is, so alkynyl halides means from alkene, hydrogen is replaced by the halogen, then we will get the alkynyl halides. For example, CH2 double bond CH2. What is the name of this? Totally two carbons are there, eth, and it is a double bond is there, so ene. So what is the name of this? Ethene. So in this hydrogen place, halogen is replaced, then CH2 double bond CH, in the place of hydrogen, halogen is replaced, then CHX will come. So this is called alkynyl halides, ene. So from the alkene, means in a alkene, hydrogen is replaced by the halogen, then we will get the alkynyl halides. And next one, third one is the alkynyl halides. So alkynyl halides means in alkyne, hydrogen is replaced by the halogen. Then alkynyl halides will form. For example, CH triple bond CH. Here in this place of hydrogen, halogen is replaced. Then CH triple bond CX. So these are called alkynyl halides. Means here YN. So from the alkyne, hydrogen is replaced by the halogen, alkynyl halides will come. Next, from the alkene, ene. So from the alkene, hydrogen is replaced by the halogen, alkynyl halides will get. Next, alkyl halides means from the alkane, hydrogen is replaced by the halogen, then it is known as alkyl halides. So this is, and the fourth one is the aryl halides. Aryl halides. So aryl halides means these are the derivatives of aromatic compounds. Aromatic compounds, for example, benzene. Benzene, this is the, what is the formula of benzene? C6H6. So each carbon having one hydrogen. So now this hydrogen is replaced by the halogen, then we will get the aryl halide. Aryl halides. So these are the aryl halides. Aryl halides means the hydrogen from the aromatic compounds. These are the aromatic compounds is replaced by the halogen, then we will get the aryl halides. So this is the first classification. First one is the alkyl, second one is the alkynyl, next third one is the alkynyl, and fourth one is the aryl halides. So this is the first classification. Next, again alkyl halides classified into different types, that is the monohalides, second one is the dihalides, and next one is the trihalides, and next one is the perhalo compounds also. So now in this monoalkyl halides, first one is the monoalkyl halides. So monoalkyl halides means, alkyl halides means what is the meaning? From alkane hydrogen is replaced by the, from alkane hydrogen is replaced by the halogen, then these are called alkyl halides. Only one hydrogen is replaced by the halogen, then monoalkyl halides will form. For example, CH4, this is a alkane. So in this, one hydrogen is replaced by the halogen, then CH3Cl will come. So how many hydrogens are replaced? Only one hydrogen is replaced by the halogen. So that's why these are the monoalkyl halides. Monoalkyl halide. For example, CH3, CH2, CH3. Here one hydrogen is replaced, then CH3, CH2, CH2Cl. So this is the one of the example of monoalkyl halide. Means only one hydrogen of the alkane is replaced by the halogen, corresponding number of halogens, then it is called monoalkyl halides. Next, second one is the dialkyl halides. Dialkyl halides. So dialkyl halides means two hydrogens of a alkane, two hydrogens of a alkane replaced by the two halogens, then it is known as dialkyl halide. For example, CH4. So two hydrogens replaced means remaining two hydrogens, then CH2, and those two hydrogens are replaced by the two halogens, so CH2X2. So this is the dialkyl halide. So dialkyl halide means two hydrogens of a alkane is replaced by the two halogens, then it is known as dialkyl halides. Third one is trialkyl halide. So trialkyl halide means three hydrogens from alkane is replaced by three halogens. So now, for example, CH4. So out of four hydrogens, three hydrogens are replaced by the three halogens. Then out of four, three hydrogens are replaced, then remaining only one hydrogen, then three hydrogens place, three halogens will come. So CHX3, for example, CHCl3, CHI3, chloroform, iodoform, bromoform, CHBr3, like this. So these are, out of four hydrogens, three hydrogens are replaced by the halogens, so that's why these are the trialkyl halides. And next one is the fourth one is the perhalo compounds. Perhalo compounds. So perhalo compounds means total number of hydrogens. Total all hydrogens from a alkane is replaced by halogens, all hydrogens. For example, CH4. How many hydrogens in this alkane? Totally 4 hydrogens are present. So 4 hydrogens also replaced by the halogens, then CX4 will come. For example, CCl4 or CCl4, carbon tetrachloride, like this. One more example, for example, C2H6. This is a ethane. So how many hydrogens are there? 6 hydrogens. 6 hydrogens also replaced by the 6 chlorines, like this C2Cl6. So this is also example of perhalo compounds. So perhalo compounds means in a alkane, how many hydrogens are there? Those many hydrogens also replaced by the halogen, then those are the perhalo compounds. So this is alkyl halides, one classification. And after that, in this monoalkyl halides again classified into different types. So monohalides means what is that? In alkane, monoalkyl halides means in alkane only one hydrogen is replaced by the halogen, that is the monohalides. So here monohalides again classified into primary halides, secondary halides and tertiary halides. So this is the classification. This is the based on nature of the carbon. Halogen attached carbon, nature, based on the nature. These monohalides again classified into primary, secondary and tertiary. So now coming to primary halides. What is the primary halides? Primary halides means halogen is attached to primary carbon. Halogen is attached to primary carbon. Those are the primary halides. For example, CH3, CH2, Cl. CH3, CH2, Cl. Here, halogen is attached to this carbon. So, this carbon is a, which carbon we have to check. Here, around the carbon, only one carbon is there. Then this carbon is a primary. Next, around this carbon, two other carbons are there. Two other carbons, then this carbon is a secondary carbon. Next, around the carbon, three other carbons, three alkyl groups are present like this. Then this carbon is a tertiary carbon. Now, Cl is attached to this carbon. Around this carbon, how many carbons are there? Only one carbon is there. So that's why it is a primary carbon. So halogen is attached to primary carbon. So it is a primary halide. Next, one more example. CH3, CH2, CH, CH3, CH2, Cl. This is one of the example. Now, halogen is attached to this carbon. This carbon you have to check this is a primary or secondary or tertiary. So around this carbon, how many carbons are there? Only one carbon is there. So it is a primary carbon. So halogen is attached to primary carbon. Halogen is attached to primary carbon. So it is a primary halides. So like that you have to check. Next, second one is the secondary halides. So what is the meaning of secondary halides? Secondary halides means halogen is attached to secondary carbon. Halogen is attached to secondary carbon, then it is a secondary halides. For example, CH3, CH, Cl, CH3. This is the example of secondary halide. Why? Because here chlorine is a halogen. So halogen is attached to this carbon. So you have to check this carbon is a primary or secondary or tertiary, you have to check. So this carbon, around this carbon, how many other carbons are there? Two other carbons are there. So that's why it is a secondary carbon. Secondary carbon. So that's why halogen is attached to which carbon? Secondary carbon. So that's why this is the example of secondary halides. So this is one of the classification and secondary halides. And next one, that is the tertiary halides. So tertiary halides means what is that? Halogen is attached to tertiary carbon. Halogen is attached to tertiary carbon. For example, CH3, C, CH3, CH3, Cl, CH3Cl. Now halogen is attached to this carbon. So this carbon, check. Around this carbon, how many carbons are there? 1, 2, 3. So 3 other carbons are there. So that's why this carbon is a tertiary carbon. So halogen is attached to tertiary carbon, so that's why it is a tertiary halides. So like that you have to check. And next one, so this is the nature of the carbon, means that carbon is a primary or secondary or tertiary. Based on that, halogen is attached to primary carbon, that is the primary halides. Secondary carbon means that is the secondary halides, and tertiary carbon means that is the tertiary halides. Like that you have we can calculate. Next, after that, monohalides, one more classification based on the hybridization halogen attached carbon. Based on this carbon hybridization, if it is sp3 or sp2, based on the hybridization of carbon which is attached to halogen. So here sp3 hybridized carbon, if sp2 hybridized carbon, if halogen is attached to sp3 hybridized carbon, again classified into three types. That is the first one is the alkyl halide, second one is the benzyl halide, and third one is the, what is that, alkyl benzyl allyl halides. So this one. Next, based on sp2, again two types, that is the aryl halides, and next one is the vinyl halides. So this is one more classification. So now coming to the halogen is attached to sp3 hybridized carbon. Then first one, what is that? Alkyl halide. So first alkyl halide. What is the alkyl halide? Already we discussed. What is the alkyl halide means? In alkane, from alkane, hydrogen is replaced by the, in the alkane, hydrogen is replaced by the halogen, we will get the alkyl halide. So one more definition, alkyl halides. For example, CH3 CH2 Cl, CH3 CH2 Cl. Now Cl, halogen is attached to this carbon. This carbon is which hybridized carbon? This is the sp3 hybridized carbon. Why? Because how to check the, that is the sp3 or sp2 or sp, means around the carbon all four single bonds, means that is this carbon is belongs to sp3 hybridized carbon. Next, around the carbon double bond is there, then this carbon is the sp2 hybridized. Next, around this carbon triple bond is there, means that is the sp hybridized carbon. So now halogen is attached to this carbon. Around this carbon, observe, this side single bond, this side single bond, and two hydrogens always single bonds only. So totally around this carbon four single bonds only is there. So that's why this is a sp3 hybridized carbon. So what is the definition of alkyl halides? Means halogen is attached to sp3 hybridized carbon of a alkyl group. sp3 hybridized carbon of a alkyl group, then it is known as alkyl halide. For example, one more, CH3 CH Cl CH3. Here also this is also alkyl halide. Why? Because halogen is attached to this carbon. This carbon around totally all single bonds only. So that's why it is a sp3 hybridized carbon, and this group is a alkyl group also. So halogen is attached to sp3 hybridized carbon of a alkyl group, then it is known as alkyl halide. So this is one more definition for alkyl halide. Next, second one is the benzyl halides. So what is the benzyl halide? Means halogen is attached to sp3 hybridized carbon, which is adjacent to the benzene ring, then it is known as benzyl halide. Here see, halogen is attached to this carbon. Around this carbon all single bonds only, no? So this is a which hybridized carbon? sp3 hybridized carbon. Halogen is attached to sp3 hybridized carbon, which is, means this sp3 hybridized carbon is adjacent to the benzene ring, is adjacent to the benzene ring, then it is a benzyl halide. Halogen is attached to sp3 hybridized carbon which is adjacent to the benzene ring, then it is known as benzyl halide. Next, after that, allyl halide. Allyl halide means halogen is attached to sp3 hybridized carbon which is adjacent to the double bond, which is adjacent to the double bond. So this is the double bond. Next, adjacent carbon, this is the adjacent carbon, this should be sp3 hybridized carbon. Why? Because around the carbon two single bonds and two hydrogens ch2 like this. For example, ch2 double bond, ch single bond, ch2 cl, ch2 cl. This is the example of allyl halide. Here, how can you identify? Halogen is attached to this carbon. This carbon is a which hybridized carbon? sp3 hybridized carbon. So which is adjacent to the double bond, which is adjacent to the double bond. Here, benzyl halide means halogen is attached to the sp3 hybridized carbon which is adjacent to the benzene ring, that is the benzyl halide. Allyl halide means halogen attached to sp3 hybridized carbon which is adjacent to the double bond, then it is known as allyl halide. So this is based on the halogen attached carbon hybridization, based on the hybridization. So that is the sp3 hybridized completed. Now sp2 hybridized carbon, sp2 hybridized carbon, halogen attaching carbon is a sp2, then again classified into two types, that is the aryl halides and second one is the vinyl halides, aryl and vinyl. Now aryl halides, already we discussed this aryl halides. What is the aryl halides? From aromatic compounds, from aromatic compounds, for example benzene. Here hydrogen is replaced by the halogen, then we will get the aryl halides. So that is one of the definition. And one more definition, here halogen is attached to this carbon, this carbon. So this carbon, around this carbon double bond, this circle means what is that? Alternate double bonds only. So around this carbon double bond is there, so that's why it is which hybridized carbon? sp2 hybridized carbon. So halogen is attached to sp2 hybridized carbon of a benzene ring, of a benzene ring, then it is known as aryl halide. For example, one more example, chlorobenzene, chlorobenzene. So here halogen is attached to this carbon. So this carbon is which hybridized carbon? sp2 hybridized carbon of a benzene ring. So that's why it is a aryl halide. Next, after that, vinyl halide. So vinyl halide means halogen is attached to sp2 hybridized carbon of a double bond only. Here halogen is directly attached to the double bonded carbon. Here halogen attached carbon, this one. So this carbon around double bond is there. So that's why it is a sp2 hybridized carbon. So vinyl halides means halogen is attached to sp2 carbon of a double bond. So this is known as vinyl halide. So here allyl halide and vinyl halide, if you are observed, allyl halide means halogen is attached to sp3 hybridized carbon which is adjacent to the double bond. Here vinyl halide means ch2 double bond CHCl, means this is the allyl halide, this is the vinyl halide. Here halogen is attached to which hybridized carbon? sp2 hybridized carbon. Here halogen is attached to sp3 hybridized carbon. Here this sp3 hybridized carbon which is adjacent to the double bond, but here chlorine is attached to carbon which is present in the double bond. Here adjacent to, here present, same like benzyl and aryl. Benzyl means what is that? Here halogen is attached to sp3 hybridized carbon which is adjacent to the benzene, but aryl halide means halogen is attached to sp2 hybridized carbon which is